In this video, we're going to be using a lot of our algebra skills in order to solve what's called radical equations. Now, radical equations are just what they sound like. They're equations that have radical signs. And so in order to solve them, we're going to isolate the radical, which means to get it by itself. And then we have to get rid of the radical by raising both sides to the appropriate power. And so if we have a square root, we're going to square it. A cube root, we're going to cube it. Fourth root, we're going to raise it to the fourth power, and so forth, because those are inverse operations. They undo one another, and it would get rid of that radical and give us just what's underneath the radical. Then we're going to solve that resulting equation. We may just be able to isolate x. We may have to factor. We just see. And then the last step is we're going to have to check for what's called extraneous solutions. We've done that before in rational equations. We didn't want to divide by 0. Here we just have to check to see if our answers really work in the original equations. So sometimes we get extra solutions. Let's look at this first example. We have a square root and it's not by itself. I want you to just highlight that and see that it's not by itself on one side of the equal sign. You have that -5. So in order to isolate that radical, we're going to add 5 to both sides. So we have the square root of 4x plus 1 equals to 5. That first step is so very important. Now we're going to get rid of the radical. Ask yourself what kind of radical you have. Of course, it's a square root. So we're going to square both sides. We always have to do the same thing to one side of the equation as we do to the other. Now when we square that square root, what happens? They undo one another and you just get what's underneath the radical. Now this side we didn't have a square root, so you have to square it. 5 squared is 25. Now after that, it's pretty easy. We're just going to solve that resulting equation. So we're going to subtract 1 from both sides, and we have 4x is equal to 24, and then we're going to divide by 4, and we're going to get x is equal to 6. And then the last step is I have to check it, and I want to check it back into the original equation. So we're going to see if 4 times 6 plus 1, the square root of that, minus 5 is equal to 0. So of course that's 24 plus 1, which is 25. The square root of 25 minus 5 is 0. So that's an okay answer to keep. And most of the time they are, but you still have to check. Let's look at the second example. Alright, again we have a radical. Is it by itself? Let's highlight it. No, that -1 is hanging out with it, so we need to add 1 to both sides. And we get the cube root of x squared plus 4 is equal to 5. And now we need to cube both sides because we have the cube root. And again, the cube root and the cube undo one another, so you just get x squared plus 4. Now 5 cubed, that's 5 times 5 times 5, that's 125. All right, now I need to subtract 4 from both sides. But I'm not done because that's x squared. Then you have to remember, well, what undoes an x squared? A square root. So we have x, and hopefully you remember, when you put in a square root that wasn't there, you have to put in that plus or minus sign, and the square root of 121 happens to be 11. Now that's two different answers, so we need to check both answers. So we're going to come up here, we're going to say, all right, if I take 11 squared, add 4, cube root it, subtract 1, do I get 4? Well, that's 121 plus 4, which is 125, and the cube root of 125 is 5 minus 1 is equal to 4. So that checks. And then if I checked -11, when I squared that, I'd get exactly the same thing. So again, both answers are okay to keep. This one looks similar. So again, we're going to isolate that radical. So we're going to subtract 6 from both sides. And we have the square root of x squared plus 16 equals to -5. Then we're going to get rid of that radical. It's a square root. So I'm going to square both sides. Negative times a negative is a positive. Now I want to solve, so just like last time, I'm going to subtract 16. And just like the last example, to go from x squared to x, I take the square root, and I don't forget my plus or minus sign. And then I have to check. Alright, so I'm going to check one at a time. So I have 3 squared plus 16 plus 6 equals to 1. That's 9 plus 16, that's 25. Well, you should know that that's 5 plus 6, and that is not 1. So positive 3 does not work. Well, what about negative 3? If I stick negative 3, I'm still going to get 9. I'm still going to get exactly the same thing. So neither one of those answers work. But again, you don't erase it, you don't scribble it out, just put one line through it, and then you can say no solution. Now it is possible that one could have worked and one not. You keep one, you cross out the other. But in this case, neither one worked, so we did all that work kind of for almost nothing. But we still have to check. All right, now we have a fourth root. Well, is it by itself? Let's see. That's all by itself on one side of the equal sign. So we can just get rid of that radical by raising each side to the appropriate power. And this time, since it's the fourth root, we want to raise it to the fourth power. And 2 to the fourth power is 16. Now this time we don't have just x squared like the last two examples. I have an x squared and an x, so that's a quadratic. So that means I have to set it equal to 0 and go from there. So let's subtract 16 from both sides. Now I have a quadratic. Hopefully we're going to be able to factor it. I think 5 times 4 will work nicely. Then I need to set each factor equal to 0 and solve. Alright, so we have two answers. Are we done? No, we have to check. Alright, so I have the fourth root of negative 5 squared plus a negative 5 minus 4. Does that equal to 2? I know that's a lot of work. So let's see, that's 25 minus 5, that's 20. Okay, so I have 20 minus 4 is 16. Is the fourth root of 16 equal to 2? Yes, it is. All right, now I need to check the 4. So I have the fourth root of 4 squared plus 4 minus 4. Well, plus 4 and minus 4 is 0. 4 squared is 16, and that equals to 2. So again, both are keepers. This time you notice we have x's on both sides, but the good news is the radical is still by itself, so we've already isolated it. And now we need to get rid of that radical. It's a square root, so we need to square both sides. And what makes this a little bit different is that x. But what's 2x times 2x? 4x squared. And when I square this, the square root goes away. And again, we have that quadratic, so I need to set it equal to 0. And this time, I'm going to move the 4x to the other side, make it negative 4x. I'm going to move the 15, and that's going to come negative. And so I need to factor it. It's a little bit harder factor because of that coefficient. Let's try 4 and 1. And I know let's see, and then 3 and 5. That may or may not work. No, I don't think that does work. So let me try 2 and 2. I think that would be okay. So let's see. 5 times 2 is 10. If I make that negative and that positive, then I get that negative 4. So sometimes you just have to try some different things to get it factored right. Then I'm going to set each factor equal to 0. And I'm going to solve for x. So I have two answers that, yes, I have to check. And I know you're going, ugh, fractions. It's not going to be as bad as you think. Now keep in mind, you have to put in x everywhere there is an x. So I have 2x equals the square root of 4x plus 15. So I'm going to check 5 halves. So 2 times 5 halves does that equal to the square root of this? Now the reason why it's not so bad is that you should be able to see that those reduce. That reduces. And so I have, does 5 equal to the square root? That's 2 times 5 is 10 plus 15. Well, yeah, 10 plus 15 is 25. Square root of 25 is 5. So that's okay. So the math really isn't that bad. So now let's check this one. Again, I can see those 2's reduce. That kind of makes that math easier. So I have, does negative 3, I should have put a question mark there because I don't know if those are equal. There's 2 times 3 is 6 plus, oh, that's a negative 6. Now 15 minus 6 is 9, but the square root of 9 is not negative 3. That square root was already there, so we cannot consider that plus or minus. So this is what's called an extraneous solution. So the answer is not no solution because we have 5 halves. That is our solution. This part is extraneous. That's what I want to see on your homework, is to have one line through it and then tell me that this is extraneous.